Okay. Yesterday we went over just those parent functions. What I want to get into now is what starts to happen when these transformations go on, and also how do you read an equation and understand what type of transformations happened. There's a couple of different things that can happen to your function. It can go up and down, it can go left or right, and it can also be reflected, or it could also be compressed or stretched. And we're going to talk about all those things and like how do you tell what's going on in your equation. We're going to start first with vertical shifts. Vertical shifts would be along your y-axis because the y-axis is your vertical line on your graph. So we're talking about shifting something up and down here. I'm going to highlight a couple of things or underline here, but when we have a function of this form, y equals f of x, and then there's a plus c. So like c could be any number if they're adding something to the end of your equation. So like we had a parent function yesterday that was x squared. If we have x squared plus something, that is going to shift it upward. And it's going to go up c units. So whatever that number is that they're adding on is going to tell you how many it goes up. Now, if the c is negative, so if they subtract it, that's going to shift it down. Okay? So when we look at these, we're going to have our parent function, but then there's going to be a number added or subtracted after it. And that's just going to be telling you that it moved the graph up or down. So we're going to do a couple of these here. That first one is x squared plus 3. So hopefully you can kind of think about a couple of things here. One, x squared is your parent graph. So that's that parabola we talked about yesterday. It looks like a U shape. Now, what is the plus 3 going to do to it? Move it up 3. So I'm going to write that next to this here. This 3 is going to cause it to go up 3. When I graph these, I'm going to want to graph the parent and the new one just so I can show that it did go up 3. So that's why we talked about those parent graphs yesterday. And remember, I said you can come up with the points by using a calculator if you need to like refresh on what point you are. But some of you might know where some of these points are going to be on this parabola because you've seen a parabola enough times. So remember, we had points at 0, 0, 1, 1, 2, 4. We also had them at negative 1, 1, negative 2, 4. That's how we get that U shape. So this is the original graph. Now I want to graph the new one. And so all I need to do is take those original points and they all need to go up 3. So my red graph is the parent, the blue one is this new graph that got shifted up 3 units. Now we're still going to be describing domain, range, increasing, decreasing, is it even or odd? Some of those characteristics are not going to change from the parent function. Some might change a little bit based on like where the domain or range is because of how it's being moved on the graph. For the most part, increasing, decreasing, whether it's even or odd, those probably won't change a whole lot if you're just moving something up or down because you're not changing the overall look of the graph. So I would still say for this one that your domain is going to be negative infinity to positive infinity. Now my range though, because the graph got shifted up, we're looking at the blue one. What's the lowest y value on my blue graph? 3, because it got pushed up 3. So that's going to just switch it from 0 infinity, what we saw yesterday, it's 3 infinity now. Okay, this will change the increase and decrease just a little bit because of that number 3. Because remember on the red graph, it would be decreasing down to 0, and then it starts to increase. But now on the blue one, we're up at that 3. So I would say that it decreases from negative infinity to 3, and then it switches and it increases from 3 to positive infinity. You guys following where I'm getting those numbers from? And then do you guys think it's even or odd? Yeah, it's still even. Okay, so let's go on to the next one. The parent is that cubic function, the cube root function. What's happening to it?
going down to?
Yeah, this one's going to go down 2. All right, this one, maybe you're a little less familiar with that cube root function, but this starts at 0, 0, and the points we talked about yesterday were at 1, 1, and then over at 8, 2. And then we also have the negative side, but that is the one that it shifts down into quadrant 3. So it kind of looks like that. And then again, you just have to shift these. So all of these are going to go down 2 points. Okay, what would you guys say for the domain?
Negative infinity to positive infinity?
Yep. Range? Range would be your y values. Now, it looks like it's maybe stuck between those numbers, but it is technically going to get bigger each time. There's more numbers that we could cube root. I'm just not able to show them because they're going to start to get really big really fast. I don't think there's any limit on our y. Like, we can put in any number for x and get any possible answer for the y. So I think we're still at negative infinity, positive infinity for our range. I know the graph is like, it seems maybe small, but we are just seeing like a snapshot of this. Remember that these continue to go in both directions. The only numbers I focused on were like 1 and 8 because those are easy numbers to cube root. The next easily cube rooted number would be 27. 27 is way far off on my graph. I don't have space for that, so that's why we're not seeing it. Is it increasing or decreasing?
Increasing.
Good, increasing. Remember, we read that left to right, so it seems to be going up over time. Even or odd or neither. What did we say yesterday about this one?
Neither.
This one was neither. All right. I'm going to give you a minute. I want you to go ahead and try this one. That last one is an absolute value function. Okay, so what movement did this one have? Up 1. Okay, so that's what it should have looked like there. Domain should have still been negative to positive infinity because I could put in any value for x. What was the range though? Good, 1 to infinity, because again, at the vertex point is kind of a stop. It doesn't go down anymore. It goes back up to make that V shape. It's decreasing, I would say, from negative infinity to 1, and then it's increasing from 1 to positive infinity. And do you still think this is an even graph? Yes, the y-axis is still symmetric. So the absolute value is still split nicely. on either side of the y-axis, so we can still say that this is even. Once we start to get into these next couple of problems where we're shifting things left and right, that's going to start impacting whether things are even or odd. So remember, even symmetry is when the y-axis can cut right down the middle and it looks the same on both sides. Odd symmetry is around the origin. So if the origin is where it appears to kind of split off, half into quadrant 1, half into quadrant 2, then that's going to say that it's odd. That's why on the second one, the parent function was odd from yesterday. But because that graph got shifted down, it's no longer being flipped around the origin. And that's why we had to say neither for the second one. All right. Now let's talk about horizontal shifts. Okay. Horizontal would be moving it left and right, so along the x-axis. This time they're going to be written a little differently. Your change, like the number you're looking for, is going to be inside the parentheses, the brackets, whatever it is that they're giving you with the x. So instead of being on the outside, it's now going to be on the inside with your variable. So this is going to say like x plus 3 or x minus 3 in those symbols. If you see a plus 3 or a minus 3, you are going to have to train your brain to think backwards here. And you've probably been talked to about this even when you were in Algebra 1 because we did do some, or sorry, Algebra 2 because we did do some of this translating. When it's a plus C, that actually means it went left. And when it's a minus C, that means that it actually went to the right. It's a little bit backwards from what we think based on what we see on a graphic when we're thinking about negative and positive. When we think negative, we think to the left. But it's got a plus sign because whatever number you put in was negative, and that's what causes it to move that direction. So just be careful of that. All right, so let's do a couple examples for this one. Hopefully you can kind of notice a little bit of the difference in the notation here. Everything's underneath the square root sign, in the parentheses, in the brackets. So for this first one, what is this minus 1 going to do? Yeah, this is going to go to the right one. Let's just go over to the next one. What is this plus 2 going to do?
Left 2.
Yep. And how about this last one, the plus 1?
Left 1.
Good. Okay. This original graph on this first one is a square root function. So remember what square roots look like. It's only positive. It's like half of a parabola up there in quadrant 1. Remember, we got those points because we were putting in numbers for x that were easily square rooted. Okay, but this one is going to move everything to the right one. So my new graph is I'm going to take all those points and I'm going to go one to the right with them. All right, what would be our domain? Be careful with the domain here. Good, 1, positive infinity. You're reading the blue graph now. The red one is just there to help you get those points that you're going to have to move. How about the range? What's the lowest y?
0 to infinity.
Yeah, 0 to infinity. Good. Is this graph increasing or decreasing?
It's increasing.
Increasing on what interval?
1 to negative 2 infinity.
Good. Even or odd or neither? Does it reflect over the y-axis? Nope. Does it reflect around the origin?
Nope.
Nope, so this is neither. Okay, next one. We are back to a cubic function here, so x to the third would be our parent. So remember that one is 0, 0, 1, 1, 2, 8, negative 1, 1, negative 2, negative 8. That's our parent function. We said that the new one should move left 2. So all those points we need to go left 2. Again, if you need help with getting those points, the yellow calculator's in here. You can type in the equation on your table and it'll just spit out these numbers for you to graph. Because right now I'm not so focused on like, can you evaluate numbers in this function? I'm more so, can you explain to me what's happening with the graph? All right, so describe to me here with this blue graph, what's the domain? Good. Range. Same thing. Is this graph increasing or decreasing? From negative to positive infinity again. Now, the blue graph, is it even, odd, or neither? Remember, even would be, does the y-axis split that graph down the middle in half perfectly? It's not even. It's neither, because it also doesn't get split around the origin. Now, the original graph that we talked about yesterday was odd because it got split around the origin. But because it got shifted to the left, it's moving away from the origin here. It's no longer going to be symmetric. Okay, this last one we saw a little bit ago, that absolute value graph. This time it goes left 1. What's your domain? Good. Range?
-1 to infinity.
I still think it would be 0, wouldn't it? It's on the y-axis.
Oh, yeah.
Increasing, decreasing? Both. It's decreasing from where to where? Good, to -1. And then it's increasing from, good. Odd or even, or neither? The blue one, not the red one. Neither this time. Because it got shifted over, it's moving away from the even symmetry. So this is neither. I know, we got a bunch more to go. I'm giving you plenty of examples so that you know how to do this on your own. Are we feeling a little bit better about those though? Hopefully you're starting to recognize patterns, or you just are starting to see like, okay, these graphs are going to start to look this way all the time. All right, that was all about moving it up and down, left and right. Now let's talk about reflections.
Oh God, may I use your restroom real quick?
Now I want to do reflections.
Okay, reflections. There's two ways that something could be reflected. It can be reflected over the x-axis or the y-axis. In order for it to be a reflection over the x-axis, okay, so I'm going to highlight x-axis, the whole function is going to get negated. So if there's like a minus sign sitting, like I kind of highlighted where that minus sign is, that negative sign that's sitting in front of the function is going to change the signs of everything involved. That is going to cause this to be reflected over the x-axis. That just means you're going to take your graph and you're just going to flop it over the x-axis like a mirror. Okay, so if you think about this one, and we can continue to still like talk about domain, range, and all that stuff. They don't have that stuff listed out, but we could still describe that information. This first one is a square root. Okay, so remember your square root function. I'm just going to graph the parent graph right now. So there's your square root function. What is the -1 underneath the square root going to do?
Down. Right.
Which is it? Is it down or is it right?
Right. Down. Right.
It's underneath the square root sign.
Right.
So it goes right. If it wasn't underneath the square root sign, then it would be going down. But it's underneath that symbol, so that's going to move it left or right. Okay, so it's going to go right one, and then it's going to get reflected because of this negative here. This is going to cause it to reflect over the x-axis. Okay, so here's what you should do. You're going to take those original points, and you're going to think about 0, 0 is going to go right 1, and then it would be reflected over the x-axis. Well, it's on the x-axis, so it's going to stay there. Then you're going to go to 1, 1. You're going to move it right 1, and so it would be like right here, right now. But then you have to reflect it over the x-axis, so that's going to actually shift it down below. Did you guys follow that? We're going to do it again. I'm at 4, 2 right now. I would go right 1, so it would be right here, but then I have to reflect it. It's right now 2 above the x-axis, so to reflect it, I need to go 2 below. And then we would do the same thing with that last point that we have at 9, 3. I would go right 1, which is going to go off my graph, but then I would go down to do my reflection. So it's going to look like that. So they are going to start to combine some of those movements that we've been seeing, where they're moving it left or right, up or down first, and then you're having to perform the reflection. Now we can still describe domain, range, all of that stuff here for this graph. So what would be your domain? For the blue line, what are your x values that appear to be used on that blue one? 1 to positive infinity. Yep. How about my range? What are your y's doing? It's going down, so that would be negative infinity. Is the blue line increasing or decreasing? Decreasing from 0 to negative infinity. And then odd, even, or neither? Neither, right? There's no symmetry there. So if you look at these other two, again, notice how there's a minus sign here and there's a minus sign here. That's what's telling us that this is going to reflect over the x-axis. Now for that middle one, it's going to also start to shift it left or right, okay? So here's what I'm going to have us do for the next couple. I'm going to have us graph them, but I'm not going to have us answer all the domain, range, increasing, decreasing stuff, okay? I think you guys are starting to get the hang of understanding how to describe what's going on with your graph, okay? I want us to just focus on what would these graphs look like. So if you look at that middle one, yes, it's reflected over the x-axis because of the negative, but what is that plus 2 going to do? Good. This is going to go left 2. And if I were you, I would be marking up your pictures like I am. I would be circling those numbers and writing right above it. What's it going to do? Just as a reminder to yourself so that you know how to handle it. Now, this is a cubic function, so we're going to be at 0, 0, 1, 1, 2, 8, negative 1, 1, negative 2, 8. Again, that's just your parent graph. Okay, and then we have to think about what's going on here. So I'm going to kind of zoom in. We're going to go a point at a time. It's going to go left 2, and then it's going to be reflected over the x-axis. So if you start at your origin, 0, 0, you're going to go left 2, which would be right here. Now, if you reflect over the x-axis, again, it's going to stay because you're on the x-axis. Now, if I'm at 1, 1, I'm going to go left 2. I'd be here. But then I have to reflect. So where's it going to go? I was at 1, 1, and I went left 2. I drew a little X there. Where should I put my final point, though, if I reflect over the x-axis? Yeah, it should be down here because it's got to go down below. Same thing with the 2, 8. If I go left 2, My x up there at the top is just the left 2 movement. But if I reflect it, where does it go? -8. Okay, I'm going to get rid of those x's just so you're not getting confused. Then we're going to do the same thing with these other negative points. So I was at -1, -1. I go left 2. That would be right here. But then I have to reflect it. This time, these ones are going to go up above the x-axis because of my reflection. And then same thing with -2, -8. I go left 2, 1, 2, and then you're going to go up. So it should be here. Okay? Now just really quick, I'm not going to write it down, but the domain for this one would still be negative to positive infinity because it's still all my x's are okay. Range would also be negative to positive. The original red graph, I would say, is increasing. What's now happening on the blue one? Is the blue one also increasing or is it now decreasing?
Decreasing.
It's decreasing now over time, okay? And then I would say it's neither odd or even because it's not going to be reflected at all, like along the x or the y-axis or the origin. Did you guys follow how I graphed that? Okay. Let's do this last one and then we'll probably call it good for today and we'll have to finish the rest of this up probably tomorrow. Okay. This one is a little bit simpler because it just has a minus sign, so it's only a reflection. What kind of graph are we dealing with here? Yeah, so absolute value. Like I said, this one's a little easier. You're just doing a reflection, so the whole V is just going to drop down. Okay, I'm not going to write it out, but what would be your domain?
0. Oh wait, are we doing the blue one?
The blue one. Domain would be your x's.
So negative infinity 0. Or just negative infinity. Oh.
Negative infinity to positive infinity. I could put any numbers I want in for x. Your range, though, would be what? 0 to negative infinity. It's increasing on the left. It's decreasing on the right. Is it even, odd? This one would be even because that y-axis is still splitting it in half. Good. All right. We do have some more left. We'll finish it tomorrow.